right, here we go. So most of this is actually review from our derivative chapter and our integral chapter. There's just, I think the net change is the only thing that's actually new. So S, remember, is called displacement or position of the particle from a fixed origin at time t. Also, remember velocity. Velocity of a particle is given by v of t equals s prime of t. Velocity is also considered to be a vector for those of you who have done physics. It has direction and magnitude. Speed is the absolute value of velocity. A is referred to as the acceleration. And acceleration is the derivative of velocity or the second derivative of position. What's cool, and what we did earlier in chapter 13, so we're kind of just, this is recalling. These are things you already know. Given the velocity function and what's called a boundary condition, you can use an indefinite integral to find the displacement function. And if you're given the acceleration function and a boundary condition, you can use an indefinite integral to find the velocity. Again, that's all things we've done previously. Now, in this chapter, you're going to learn the definite integrals related to kinematics. And kinematics is motion of an object. So here's what I want you to see. If velocity, v is the velocity function, you can find the displacement by doing the integral of v of t. It's s of time 2 minus s of time 1. Displacement is where are you with respect to where you started. Okay, it's not necessarily at the origin, but initial, like time 0. Now, total distance is the integral of the absolute value of the velocity function. So let's look at example 1 together, and this will make a whole lot more sense. Example 1 says a particle moves along a straight line such that its displacement, s, in meters from an origin O is given by s of t. It says find the velocity of the particle at time t. What do you need to do to find the velocity? Good job. Okay, the velocity is the derivative of your position function. So that's 2t minus 4. Find when the particle is moving to the right and when is it moving to the left. So what do we need to figure out? You're right, what's negative or positive? You need to find where the velocity is positive and where the velocity is negative, okay? But before we do that, we need to set the velocity function equal to 0, and then we'll do our sign chart. So you add 4 to both sides and divide by 2. Now, do you understand? You got to pay attention to these intervals. This is saying time is 0 to 5. So I'm going to put 0 and 5, and velocity is equal to 0 at time equals 2. So I'm going to pause a moment, and I want you to figure out where is velocity positive and where is it negative. So you do a test point. So suppose I plug in t is 1. 2 minus 4, that's negative. And then let's suppose I pick 3, that's positive. So the particle is moving right from 2 to 5, but you don't use brackets, okay? You don't use those because it's it's at rest otherwise. And then the particle is moving left from 0 to 2. And when the velocity is 0, the particle is at rest. It says draw a motion diagram for this particle. So let me show you something. And we did this earlier, back in chapter 3, I believe. Okay, so what I need to do is I need to find where is the position of the particle at time is 0. That's the initial location. So if I plug in S of 0, what do you get for S of 0? 3. So what this means is that the particle is starting at 3. And this is, I don't know if it's feet. Oh no, it's in meters. It says S is in meters. Okay, sorry. So I'm starting at 3 meters. And at time is 2 seconds, it's going to change direction, right? So from time is 0 to time is 2, the particle is moving left. So let's go find S of 2. So you would do 2 squared minus 4 times 2 plus 3. And what do you get for the position then? -1. So what this means is after 2 seconds, the particle has gone left until it hit -1. So I've got an arrow here because the particle's moving left. Then we have S of 5 is, it's now moving to the right from time is 2 seconds to 5 seconds. So let's find the position of the particle at 5 seconds. So go plug that into S of t, do S of 5. What do you get for S of 5? 8. Okay, so now what this means is the particle was sitting at -1 or left 1 unit. And it's going to travel, and it's now at 8 to the right.
So when you do these motion diagrams, you always use the position function?
Yes. Yes. Mm-hmm. So now displacement is where am I from your starting point? So we're going to start with the motion diagram. Where did we start again? We didn't start at the origin. Where did we start? At 3. And we landed when we were done at 8. So what is the displacement? How far are we from the starting location? 5. Now, if this had been like 3 and I landed at -2, that'd be 5 left, okay? So you would, put a sign with that. So I'm 5 to the right. Now, total distance is how far has the particle moved? Well, it went 4 to the left. And then how many to the right? 9, right? So the total distance the particle went was 13 meters. Now we got that from the motion diagram. Now, what I want to show you is this we're going to use the boxes up here. Displacement can be done with the graphing calculator. This is from 0 to 5 of the velocity function. So do you guys remember how to do this on your calculators? So go ahead and grab your graphing calculators and make sure before the day before the exam, make sure your calculators are fully charged. I have a charging dock here, but you do not want to walk into the exam, you know, with a dead calculator. And that's really day 2.
What mode should we have our calculator?
I would have it in radians, and then the only time you need to sort of toggle out of it is if you were doing some kind of right triangle where you need to get degrees, then you're going to switch it. But in general, I would leave it radians. And then you'll know, like it'll say, okay, find the angle in the triangle, you don't want radians.
Oh.
Yeah. All right, so in case you need a little refresher, you open a new doc, go to menu, calculus, and do numerical integral. And so you're going to go 0 to 5. I would probably just leave it as x, do 2x minus 4 dx, but if you want to do t, you can. And do you see it verifies the 5? And then total distance is the absolute value of velocity. Go ahead and type this one in and verify that you do in fact get 13. You guys got it? Yeah. Do you see underneath the control button in the equals? Do you see? I think that's the absolute value symbol there. Where you control, yeah. You see. Got it. So you hit control in the equals, and there's the absolute. There it is. You're welcome. All right, everybody good? Want to make sure you know where your buttons are.
Yeah, it didn't work.
It didn't work?
Yeah, I marked down particular absolute value.
It says syntax error. All right, let's.
Oh, you have to hit the button next to the book button. Under the delete button. And then describe where it is.
Oh, okay. All right, thank you. So you do control and the book button?
No, it's
Oh.
the button next to
Next
it.
to
and
it.
You don't have to hit control.
Oh.
What's the book button?
Oh, do you see beside the 9? You're going to hit the button beside the 9. There's your absolute value. Thank you, JJ. There's absolute value. Thank you. 2x, glad we got that one, minus 4. There we go. Yep. And do you notice, like on mine, it's giving me 13.000000 and then a 743. The way that the calculator is programmed, like it's doing an estimation. So, but thankfully, the 3 significant digits we're at 13 is just fine. All right, questions, thoughts about that first one? All right, let's look at a diagram. Example 2 says the velocity. So this is really, really important. This is a velocity graph, not a position graph. Let me say that again. It says this is the velocity graph. Moving along a line is shown. Find the particle's displacement and distance traveled over the interval 0 to 11 seconds. Well, the displacement should be the integral from 0 to 11 of v of t dt. If you notice, I have no function. I don't have a function for the position, and I don't have a function equation for velocity. However, what do you remember about the basic concept of an integral? It definitely is the inverse of the derivative, but graphically speaking, it's the area under the curve, okay? It is the area under the curve. So guess what I'm gonna do? I'm gonna call this area 1, area 2, and I'll make this area 3. But what you need to know with an integral, if the region is below the x-axis, that area is negative. So I'm gonna pause a moment, and I want to give you a head start and see if you can find the area of those 3 regions. Your first region is a trapezoid. So remember, 1/2 the perpendicular height times the sum of the parallel bases. Then region 2 and 3 are triangles, where you can do 1/2 the base times the perpendicular height. So go ahead and compute those. Add your 3 areas together where area 2 is below, so you'll subtract that amount. If you've done it correctly, that answer should be 10.5. Okay, if you do it correctly, your answer should be 10.5. One half the perpendicular height times the sum of the parallel bases. So isn't the height 3? And then this is 2 plus 6. Then I'm going to subtract 1/2, the base is 3, and my height is 3, plus 1/2, the base is 2, and the height is 3. So when you do that, you get 10.5, and this is meters squared. Now, to get the total distance is 0, the integral 0 to 11, but it's going to be the absolute value of v of t dt. And all that's going to do is change that to a plus sign. Okay, it's just going to flip that part up. So I had 12 plus 9/2 plus 3, and I got 19.5 meters squared. Or not meters squared, sorry, just meters. I don't know why I put a square there, sorry. Because the integral of velocity is position, so it's not meters squared. All right, so big idea here, an integral is the area under the curve. If the area is below the x-axis, that's represented by a negative, okay? When tackling questions, remember that initially means at time equals 0. At rest, velocity is 0. Moving right or up means the velocity is positive. Moving left or down means the velocity is negative. If velocity and acceleration have the same signs, it means the particle is speeding up. If velocity and acceleration have opposite signs, it means the particle is slowing down. All right, I'm going to give you a couple of minutes head start on this one. I want you to get as far as you can. Example 3 says a particle moves along a horizontal line. The particle's displacement in meters from an origin O at time t seconds is given by S of t equals 4 minus 2 sine 2t. Find the particle's velocity and acceleration at any time t. So go ahead and do that. Find the particle's initial displacement, velocity, and acceleration. So initial for all three of those. Part C, find when the particle is at rest, moving to the right or moving to the left during 0 to pi. Find the displacement of the particle after pi seconds. All right, do as much of that as you can. Just to make sure you have the right foundation, velocity is the derivative of position. So don't forget the chain rule. That's -4 cosine 2t. Acceleration is the derivative of velocity. Excuse me. And remember, derivative of cosine is negative sign. So that's going to be a +4 sine 2t times the 2.
I have a question.
Yeah.
What's like initial displacement? Is it just displacement?
Initial means at time t is 0.
Okay.
All right, so the initial displacement means position is 0 meters. Oops, sorry. Just kidding. Got it. It was 0 plus 4, so that's 4. Then the initial velocity is -4 meters per second. And the acceleration, initial acceleration would be 0 meters per second squared.
Oh, so the initial displacement is just you put it in the position.
Yes. Find when the particle is at rest. So this is where -4 cosine 2t is 0. So I'm going to divide by the -4. Well, this would equal pi over 2 or 3 pi over 2 for 2t. So t is pi over 4 or 3 pi over 4. Now this would definitely be a calculator problem. So what I would recommend you do, because it would be way faster, is pop -4. You got to put the velocity function in, okay? Put in -4 cosine 2t in your graphing calculator and check the intervals. Where is it above the x-axis? Where is it below? That's telling you where the velocity is positive or negative. So I got negative, positive, negative. So it's moving right from pi over 4 to 3 pi over 4. And the particle's moving left from 0 to pi over 4 union 3 pi over 4 to pi. Then it says find the displacement of the particle after pi seconds. So that's 0 to pi, and you want the velocity function. And I got 0 meters, so it's right back at the origin. But could you do that integral by hand? We should be able to. Okay, we should be able to. Yeah.
I'm gonna put C still, but how does 2t equal pi over 2?
Oh, okay. Do you remember on a unit circle? This is 1, 0, 0, 1, -1, 0, 0, -1. And you remember every x comma y goes cosine theta comma sine theta?
Yeah.
So cosine is my x coordinates. That's at pi over 2 and 3 pi over 2. So you're asking yourself, the cosine of what is 0? That's pi over 2 and 3 pi over 2. It just so happens to not be theta, but it's 2t. So you've got to account for the 2t. So you have to divide by 2. All right, let's take a look at example 4. A particle moves along a straight line so that its velocity is given by this function. When t is 0, the displacement s of the particle from a fixed origin is 5 meters. So this is saying s of 0 equals 5. Find an expression for s. Well, you remember that s of t is the integral of the velocity function. So we're going to integrate 4 sine t cosine squared t dt. Well, in order to integrate this, we're going to need to use u substitution. We're going to say u is cosine t, du is negative sine t dt. I don't have a negative, so I'm going to divide by the -1. So I'm going to rewrite this, and I'm going to pull the 4 out. So this is going to be -4, the integral, u squared du, because sine t dt is negative du. So then this integrates to -4/3 u cubed plus c, and that's the position function. So it's -4/3 cosine cubed t plus c. Now they gave us the initial displacement or initial position is 5. So we're going to say 5 equals -4/3 cosine cubed 0 plus c. Well, cosine of 0 is 1. So that's 19/3 plus c. So my position, or 19/3 equals c. So S of t now is -4/3 cosine cubed t plus 19/3. So you can actually use an integral, and we did this previously, okay? This is actually not new. We're just including trig functions with it. You can actually use an integral to find the position function if you have what's called a boundary condition. And the boundary condition is they gave us that the initial time, the displacement is 5 meters. All right, questions on that one? So like this part, we should be good with now. Okay, that's what we did in 13.1 to 13.3. Yeah, Bailey? I'm not dividing by -4/3. I added, yeah, no, I added. Okay, so now if I want to find acceleration, acceleration is the derivative of velocity. So I come back up here and I've got to do the product rule. So I'm going to take the first times the derivative of the second. So that's 2 cosine t times negative sine t, that's the chain rule, plus the second times the derivative of the second, which is 4 cosine t. Let me tidy that one up. So I have -8 sine squared t cosine t plus 4 cosine cubed t. Then it says find acceleration, velocity, and speed of the particle when t is 6. So I'm going to do s of 6, v of 6, and a of 6. You may use a calculator. So I'm going to give you a moment. Use your calculators. If you're a fast worker, then answer the question in part D. Determine whether the particle is speeding up or slowing down at t is 6. Yeah. Sure. Yeah. Oh, it didn't say, it said speed, sorry. I didn't need position. So silly. So I got velocity was -1.03 meters per second. So then the speed is 1.03 meters per second. I got acceleration was 2.94 meters per second squared. Are you guys getting that? Okay, so is the particle speeding up or slowing down? It's right up here. What makes you say it's speeding up? It's slowing down, right? Okay, the particle's slowing down because velocity of at 6 and acceleration at 6 have opposite signs. All right, then to find the displacement from 0 to 6, you're going to pop this in your calculators, and then the total distance is 0 to 6, the absolute value. So go ahead and do both of those. When you've got it, check with the board and see if you were able to punch it in correctly. I got the displacement with 0.153 meters and total distance 5.18 meters. All right, so all of that was review from earlier this year. We just were including trig functions. All right, the one thing that I do believe is new is this last one. It says the definite integral of a quantity's rate of change. So be careful. A rate of change is the derivative. So if you're taking the integral of a derivative, it is going to give you the net change from in the quantity from time 2 or time 1 to time 2. So if I have the integral of lowercase r of t, it's going to give you capital R of t2 minus r of t1, where r of little r of t is the derivative. So you're integrating it. So if you look at example 5, and this has like really, really good applications, it says a culture of bacteria is started with an initial population of 150 bacteria. That's going to be important. Okay, that's the initial population. The rate is a derivative. Let me say that again. A rate is a derivative. It says the rate at which the number of bacteria changes over a 1 month period is modeled by R of t equals e to the 0.256 t power, where R is the rate of change. So then to find the population, after 15 days, we need to find the net change from day 0 to day 15. Well, in order to do that, I'm going to integrate the rate of change. I'm going to integrate the derivative. So go ahead and do this on your calculators. Now, number of bacteria cannot be a decimal. You can't have a partial bacteria. So let's round it to the nearest whole bacteria. So what are you guys getting? I had 178 bacteria. Okay, that's the change, and that's positive, so it means it went up. If this were negative, it would mean the bacteria decreased, okay? So lowercase r of t is the rate of change in the number of bacteria per day. Capital R of t is just the number of bacteria. So the initial population was 150, and we added 178. So that's 328 bacteria. Now, if there had been no bacteria, then it would have been 178 bacteria.